Hey 8th graders, today we're going to be doing the dry ice lab, and it really curtails well off of our last lesson that we did, which was the phase change assignment. In that assignment, you guys learned that there's multiple ways that you guys can cause a phase change to happen. So for instance, you guys saw that you guys could either add to increase pressure, so you could add gas to increase pressure, or you guys could just straight up pressurize a vessel to force molecules together into the same properties that you would see with like a solid or a liquid, and vice versa. Okay, you guys can also use pressure to pull molecules apart and have them act more like a liquid or a gas. All right, so your learning targets for today, I can compare and contrast dry ice with regular ice. Obviously, regular ice is water. I can identify various phase changes involved with dry ice. So you guys have all kind of seen dry ice in action where you drop it in some warm water and you see what happens. We're gonna look a little bit more. There's more than one phase change that we see with that. And then I can identify two ways in which a phase change can occur. Okay, all right, so let's go ahead and move on to part one. So this one's gonna be dry ice versus ice. Those of you guys at home, I need you to right click and open this link up. Video looks a little bit something like this. It's a good video. I just can't understand the guy at first, but really you get to see what he's doing with a knife. He has regular water ice right here and then dry ice right there. You guys can kind of, as you work through this, find different ways to compare and contrast dry ice versus regular ice. So again, your dry ice is always on your right, your regular water ice is on the left. You guys can see the little molecular structure. You guys can observe the differences, what he does with this metal knife. He'll talk a lot about temperature and cooling, so which one cools water better. He'll talk a little bit about density, so sinking and floating. But what you guys are going to be looking for is these three things right here. So formula, how are they different? Here's regular ice, and again, your dry ice is on your right. Temperature, how do they vary in temperature? Phase change, so you guys can look at which phase change occurs with them. And then you guys get to choose a fourth way to find their differences, okay? So there's a lot of things you guys can do. I've already talked about some of them. So go ahead and type for that choice, whatever you chose. Maybe it's density, maybe it's appearance, maybe, you know, whatever the case is, cooling. He goes through a lot of different things with there. Again, at the beginning, the video is not very clear, but it does clear up a little bit for you. So that's part one. So watch that whole video. You go through a lot of differences there. Okay, part two. We will be doing this obviously in class. There's two videos I want you to watch. The first one's definitely the more quality video, but I included the second one because it's more like what we're doing in class, okay? So first one looks a little bit like this. It shows you guys giant dry ice bubbles. You've maybe experimented with this or seen this before. It's pretty fun where you make one big massive bubble of dry ice. And with the second one, you got this kind of crazy Russian scientist that's making dry ice bubbles that, again, is more similar to what we were doing in class. All right, so watch those two videos, and then you guys will answer this question, okay? And this is basically from what you've observed so far with dry ice in general. What are three different phase changes that occur when dry ice is dropped into water? So obviously, if you guys are just looking at dry ice sitting on the table, it's going directly from a solid to a gas. So what's that one called? So you guys would tell me what that one's called next to change number one. And then you would explain where you saw this occur. So again, if you're just looking at dry ice sitting on a table, you're seeing this happen, okay? If you drop it in water, this is directly from a solid to a gas, and that's the bubbles that form in dry ice. So you guys can explain either one of those scenarios. So I kind of did your first one for you guys there, but there's also two more that occur outside of the obvious. So what I want you guys to think about, and is if you've ever played with dry ice and you've messed around with this kind of white, foggy looking gas that comes off it, that's not actually carbon dioxide, okay? That's water, but when you guys kind of run your hand through it, your hand seems to get damp, okay? So what do you guys think that is? Okay, what phase change is that? Okay, again, I'll tell you this, it is not carbon dioxide, it is not liquid carbon dioxide, okay? But there is something that's making your hand wet when you guys kind of play with that fog. So what phase change would that represent? Think about what you guys have in the air. the temperature of your vessel that you have right there, the temperature of the gas coming off your vessel, what you put the dry ice in. Kind of use those to piece together what you think this somewhat apparent looking gas is. It's not a gas anymore, but what is making your hand wet and what phase change is associated with that. Next one for the change 3, I want you guys to think about what you guys kind of learned about the temperature of dry ice versus regular ice in part 1. And think about if you guys were to drop a piece of dry ice into warm water, okay, what's happening to the little environment around that piece of dry ice? Okay, so it's in water, so what do you think that dry ice is doing to the water immediately surrounding that block of ice? Okay, so that's going to be your 3rd phase change. Okay, I know that's kind of hard where you guys haven't experimented with that at home, but again, if you need to, do part 2 last and you guys can kind of watch all the videos and come back to it. Okay, part 3, everyone, whether you're in class or at home, will be watching this video. It's something I want to do in the future, but I didn't have time to get the correct pipettes. So this one's really cool. You guys have a little plastic pipette similar to what we use in class, but it's just a little bit larger. They take and they put dry ice into the bulb of that pipette, and then they seal the top of it and place the pipette bulb in warm water. So you guys actually get to see that dry ice turn into a liquid, okay? So your question to look for there as you guys watch that video and finish it up in the experiment, how were they able to turn solid dry ice into a liquid? So they turn it into liquid carbon dioxide at room temperature. Okay, so they do it all at room temperature. Normally when we see dry ice at room temperature, it turns directly into a gas. So what did they do different in their experiment that turned that solid carbon dioxide into liquid carbon dioxide and not directly into a gas? Okay. All right, and then you guys can also kind of see the results of what happens at the end of that video that turned it back into a solid or a gas. Finally, how dry ice is made. You guys kind of get a little bonus in this. You guys get a little bit more than just how it's made. But the guy talks in there about how dry ice is made. And you guys also get to see some cool experiments. One that we're going to kind of just demo in class is using a pH indicator that shows us whether a liquid is an acid or a base. So that's kind of fun because dropping carbon dioxide into it carbonates the water and makes it acidic. Okay, and then you guys can also see a couple different experiments that show, you know, how he makes dry ice at home, those kinds of things. Talks about some practical applications of carbon dioxide at different phases. So that's a cool video, so make sure you watch all of that. And then finally, answer the last question, just to kind of sum up this whole lab. What are 2 ways to cause matter to change phases? One of those, again, is talked about when they describe how dry ice is made to begin with. Okay, you guys also see one of those in part 3 where we talk about wet dry ice. And then finally, we've talked about the second one, this whole unit. Okay, it's the one that's easiest, you guys. How do you get something to change phase? So for instance, an ice cube, how do you get it to turn into liquid water? Okay, all right, so go ahead, complete that, and when you guys are done, go ahead and hand it in. If you guys have any questions, please let me know, and I will talk to you soon. Bye.